Welcome to this video, and in this video I'll be discussing a much used principle of logic, the Law of Excluded Middle. In particular, I'll be looking at some of the objections to the Law of Excluded Middle which have been put forward by primarily the Intuitionist school of mathematical thought. This video is only intended to give some basic idea of some of these objections and is not really intended to be a fully comprehensive or academic treatment of the Law of Excluded Middle. Moreover, I'll be most interested in those objections to the Law of Excluded Middle which most directly concern mathematics. In this video, I'll give a number of quotes from various authors concerning the Law of Excluded Middle, interspersed with some of my own comments to try to tie things together somehow. I don't claim to fully understand all of the quotes that I include in this video. This video, or at least the act of creating this video, is to a certain extent my way of personally coming to a better understanding of things. Therefore, there is the possibility that this video may not make much sense to others. Nevertheless, I make freely available my creation on the off chance that it does help someone somewhere. The books from which I quote various passages throughout this video are shown on the screen now. The Law or Principle of Excluded Middle, Excluded Third, Tertium Non Datur, or simply the Excluded Middle, however it's referred to, is a logical principle that roughly states, in a very informal sense, that either a proposition is true or its contradictory is true, and there's no other possibility. And this could be written schematically as A or not A, where A is a proposition, or it can be presented in a more symbolic form using modern notation as shown on the screen now, where P is a proposition. Among the first philosophers to discuss the Law of Excluded Middle at length were the ancient Greeks, and in particular Aristotle. That's not to suggest that the Law of Excluded Middle wasn't a principle that was in widespread use before Aristotle, but that it was Aristotle who evidently first abstracted the principle by considering the various kinds of things that the mathematicians and geometers at the time were doing. In Maurice Klein we read, Aristotle abstracted the principles of deductive logic from the reasoning already practiced by mathematicians. Deductive logic is, in effect, the child of mathematics. Some of the laws of deductive reasoning that Klein is talking about are syllogistic reasoning, the law of contradiction, and the law of excluded middle, amongst others. The law of excluded middle is an Aristotelian law of thought. Googling laws of thought brings up the Wikipedia article of all things wherein we read, the laws of thought are fundamental axiomatic rules upon which rational discourse itself is often considered to be based. Ludwig Wittgenstein says in his remarks on the foundations of mathematics, the propositions of logic are laws of thought because they bring out the essence of human thinking. To put it more correctly, because they bring out or show the essence, the technique of thinking. They show what thinking is and also show kinds of thinking. Although it may be a law of thought, the principle of excluded middle doesn't have to be taken as an axiom or primitive proposition in a formal system, and may indeed be derivable in a given logical system. For example, propositions 2.1 and 2.11 in Whitehead and Russell's Principia Mathematica give two forms of the law of excluded middle, along with, admittedly very straightforward, demonstrations. Though the demonstrations are almost immediate consequences of the primitive propositions and the definition of implication, the point is that the law of excluded middle is not itself a primitive proposition in the system of Principia Mathematica. The principle of excluded middle is not to be confused with the principle of bivalence, which says that a proposition has a single truth value, either true or false. These two principles, though in many ways similar and closely related, are not automatically logically equivalent, though they may be identified under certain circumstances and in certain systems. However, many authors have and do conflate the principle of excluded middle with bivalence. For example, in Ramsey we see, Vail has become a follower of Brouwer, the leader of what is called the Intuitionist school, whose chief doctrine is the denial of the law of excluded middle, that every proposition is either true or false. Or how about in Eyre, where we see the law of excluded middle, which states that a proposition must be either true or false, or, in other words, that it is impossible that a proposition and its contradictory should neither of them be true. And the following quote is from Max Black. If the law of excluded middle is stated in the form that a proposition is either true or false, its truth appears so obvious that it is incomprehensible that anybody should disbelieve it. but the apparent simplicity of enunciation conceals the difficulties implicit in the notion of truth, a notion which those who most confidently believe in the law often find hardest to explain. And it's possible that when Ramsey, Eyre, and Black wrote these comments that the two principles, the excluded middle and bivalence, were not so carefully distinguished as they are in modern logic. The distinction between the two is not the focus of this video. I won't necessarily sharply distinguish between the law of excluded middle and the law of bivalence in this video, and I certainly don't want to enter into any discussions about any formal nature or meaning of truth. I'll use the words true and truth in an informal sense, and I don't think that this will obscure any points that I want to make, or at least in this video. So here's a quote from Wittgenstein's remarks on the foundations of mathematics. When someone sets up the law of excluded middle, he is, as it were, putting two pictures before us to choose from, and saying that one must correspond to the fact, but what if it is questionable whether the pictures can be applied here? And also, in the law of excluded middle, we think that we have already got something solid, something that at any rate cannot be called in doubt, whereas in truth this tautology has just as shaky a sense, if I may put it like that, as the question whether P or not P is the case. The principle of excluded middle is a fairly universally accepted principle in contemporary mathematics. Nevertheless, it hasn't always been the case that the principle has been so widely accepted, and Wittgenstein's quotes indicate, albeit in his usual obscure way, that it may not be too absurd a notion to doubt the principle. There are several philosophical problems which relate to the principle of the excluded middle and how it's interpreted. It's often considered that a proposition is objectively either true or its contradictory is true, and that it doesn't require that we're able to determine which is true. Just because we're not able to verify or prove one way or the other, according to classical logic, the proposition or its contradictory is still true. For example, it's not currently known, as of the time of making this video, whether Goldbach's conjecture that every even number greater than 2 is the sum of two prime numbers is true or false. And this is a long-standing problem in mathematics that hasn't been proved or disproved. Nevertheless, even though we may never be in a position to prove or disprove this conjecture, the typical view on this is that Goldbach's conjecture is either true or its contradictory is true, independently of our not knowing which one. The Intuitionist school of thought, however, doesn't accept this way of thinking. They don't accept this principle, at least not in its most general applications. Of course, even to Intuitionists, if a proposition has been proved true, then it's true, and if its contradictory has been proved true, then it is true, provided that the proof proceeds along lines of reasoning acceptable to Intuitionists, which I'll say more about later in this video. But if neither a proposition nor its contradictory has been proved true, then we cannot simply say that the proposition must be true or its contradictory must be true. In Brouwer's Cambridge lectures we see, this principle, the principle of the excluded third, cannot in general serve as an instrument for discovering new mathematical truths. In Stephen Reed's book, Thinking About Logic, we read, excluded middle is a substantial statement intuitionistically. Also in Reed, the constructivist refrains from asserting that either Jones was brave or he was not. Until there is some method of deciding which disjunct is the right one, there is, he claims, no fact of the matter. And Reed goes on to say, the classicist will answer that either Jones was brave or not. He is committed universally to the excluded middle. So let's have a look at some of the comments made by A.W. Moore in his book, The Infinite. Consider the natural numbers. It's impossible for them all to be constructed within time. There is a problem with true generalizations about the natural numbers, for example, that each one is the sum of 4 squares. The Intuitionist solution to this problem is as follows. They argue that, in the case of a generalization of this kind, what we can construct is a proof which trades on the principle whereby successive natural numbers are constructed, the principle of adding 1, and which enables us to see in advance why every natural number must have the property in question. What is unintelligible on this view is the idea of an infinite coincidence, whereby it so happens that every natural number has some property, but there is no proof of this kind to show why. This quite lengthy quote is to just give some context to what Moore means by the term infinite coincidence, which will be mentioned in the next quote, which I'll shortly give. Moore goes on to introduce Goldbach's conjecture, which I've already mentioned earlier in this video, as a currently unsolved problem in mathematics, and he says of this, "It's part and parcel of classical mathematics to assume that either there is a counterexample to Goldbach's conjecture, or the conjecture is true. In recoiling from the possibility of an infinite coincidence, intuitionists cannot share that assumption. It's not that they have in mind a third possibility, it's rather that they are not prepared to invoke the assumption or others like it in the course of their mathematical reasoning. Their Aristotelian conception of the infinite thus poses a challenge to some of the most elemental presuppositions of classical mathematics." And possibly relating to the notion of infinite coincidence is in Ramsey. Vail seems to deny the law of excluded middle in a less general way. He doesn't appear to deny that any proposition is either true or false, but denies the derived law that either every number has a given property, or at least one number does not have it. A consequence of denying the law of excluded middle is that the proposition not P, or in intuitionist lingo, the absurdity of P, is equivalent to P is denied by intuitionism. From Max Black we read, "For the intuitionist, the truth of a proposition P is not, in general, equivalent to the falsity of its contradictory." And we end up with the following kind of situation described by Ramsey. Is 2 to the power of the square root of 2 rational or irrational? We cannot tell, but Brouwer would say that it was neither. We cannot find integers m and n so that m over n equals 2 to the power of the square root of 2, therefore it is not rational, and we cannot show that it is not irrational. In modern mathematics, irrational numbers are simply defined to be those numbers which are not rational. However, in intuitionistic mathematics, a number being not rational cannot be taken as implying that it must therefore be irrational. And this intuitionistic view of things can sometimes feel quite jarring and uncomfortable. The issue that the intuitionists have with the law of excluded middle is that this law originally came about through application to finite collections, but somewhere along the way its use has been extended to infinite collections, and they consider this extension to be illegitimate and unjustified. In Black we see, logic developed historically as the expression of the relationships between propositions, referring only to groups of phenomena finite in number. Hence, its laws must not be assumed to hold for the infinite subject matter of mathematics without further examination. The result of this examination shows that all the logical laws are valid except for the law of the excluded middle. And in Ramsey, the law of excluded middle, is denied apparently because it is thought impossible to know such a thing a priori, and equally impossible to know it by experience because if we do not know either that it, a proposition, is true or false, we cannot verify that it is true or false. The intuitionists devised their own version of the law of excluded middle. Here are some passages from Benacerraf and Putnam. We shall put the wording of this principle excluded middle into the following slightly modified intuitionistically more adequate form, called the simple principle of the excluded third. Every assignment tau of a property to a mathematical entity can be judged, i.e. either proved or reduced to absurdity. Then for a single such assertion tau, the enunciation of this principle is non-contradictory in intuitionistic as well as in classical mathematics. And also, for intuitionism, the principle of the excluded third and its corollaries are assertions sigma about assertions tau, and these assertions sigma only then are realized, i.e. only they convey truths, if these truths have been experienced. Brouwer himself was not interested in creating a formal intuitionistic symbolic logic, but there have been attempts to formalize intuitionistic mathematics by other followers of Brouwer with various degrees of success. In Black we read, A. Hating has recently produced a calculus of intuitionistic logic. The chief difference between this calculus and the Russellian is that the formula A or not A is not true. On the other hand, not A or not A is a true formula. This is the so-called theorem of the absurdity of the law of excluded middle. So I may be giving the impression that it was only the intuitionists who had real objections to the law of excluded middle, but in fact it was not only the intuitionists that felt the need to restrict the application of the excluded middle. David Hilbert, usually associated with the formalist school of mathematical thought, also initially restricted the use of excluded middle in his metamathematics. However, the main difference between the two schools of thought, the formalist school of Hilbert and the Intuitionist school of Brouwer, regarding the subject of the excluded middle, as far as I understand it, was that Hilbert considered a more generally applicable law of excluded middle to be derivable from certain of his axioms. Brouwer, on the other hand, did not accept this possibility. A further objection to the law of excluded middle is its role in proving existential propositions. The law of excluded middle is often used to indirectly prove the existence of an object. In Black we read, "In mathematics, the question of truth of mathematical theorems coincides with the question of the existence of mathematical entities." So the dispute between Brouwer and more orthodox philosophers with respect to the validity of the Tertium Non Datur is seen to be one as to the nature of mathematical existence, rather than as to the validity of the logical principle. Brouwer, indeed, is not denying the Tertium Non Datur in the generally accepted interpretation of that logical principle, but rather emphasizing that existence in mathematics is synonymous with constructibility. And in Vail we read, "Whenever nothing but the possibility of a construction is being asserted, we have no meaningful proposition. Only by virtue of an effective construction and executed proof does an existential statement acquire meaning. In any of the numerous existential theorems in mathematics, what is valuable in each case is not the theorem as such, but the construction carried out in its proof. Without it, the theorem is an empty shadow." In Reid's book we see, "For the constructivist, the truth of a proposition, is constituted by an appropriate construction, not a demonstration that it is true, but a demonstration of A." And Ramsey has this to say, "A more fundamental reason is put forward for denying the law of excluded middle. This is that general and existential propositions are not really propositions at all." And finally, Stephen Corner, "Pure existence theorems the intuitionist does not allow into his mathematics." A consequence of rejecting the unrestricted use of the law of excluded middle is that, for example, a real number cannot simply be classified as either rational or irrational unless a proof exists, and by proof is meant a specific construction showing that the number is rational or showing that it is irrational. In contemporary mathematics, the law of excluded middle is constantly used to prove existence theorems. During my undergraduate studies in mathematics, which was as far as I took my formal education, existence theorems were a perfectly normal thing, and in fact there was never anything to suggest to me that there was a problem. Call it naivety, but existence theorems were just accepted as a technique acceptable to mathematicians, and I'm not suggesting that this view is wrong. As I've said in previous videos, mathematicians decide what is and is not acceptable to them in their own field, and they've decided that pure existence theorems are acceptable. But it's still interesting to me to note that this view hasn't gone unchallenged and that pure existence theorems have come under fire at certain times. Any pure existence theorem which is proved by means of the axiom of choice is necessarily non-constructive, and so these types of propositions which are proved using the axiom of choice are particularly vulnerable to attack by the intuitionists. Those mathematicians more sympathetic to the techniques and results of classical mathematics were not at all convinced by the objections of the intuitionists. For example, Ramsey says, "Although it's certainly difficult to give a philosophical explanation of our knowledge of the laws of logic, I cannot persuade myself that I do not know for certain that the law of excluded middle is true." The principle of excluded middle is a fundamental principle in classical analysis. Denying the unrestricted use of the law of excluded middle requires many of the results of classical analysis to be thrown out. In Klein's book, where he's quoting Hilbert, we see, "To deny existence theorems derived by using the principle of excluded middle is tantamount to relinquishing the science of mathematics altogether." Maurice Klein suggests that the law of excluded middle is not beyond criticism in his book Mathematics, the Loss of Certainty, where he writes, "The law of excluded middle is no longer an unquestionable principle of logic, and existence proofs which do not permit calculation of the quantities whose existence is being established, whether or not the proofs use the law of excluded middle, are bones of contention. They, the intuitionists, had affirmed that it was unacceptable to establish the existence of mathematical entities by use of the law of excluded middle, and that only constructions that permitted one to calculate as accurately as one wishes the quantity whose existence is being affirmed are satisfactory. Despite Klein's comment that the law of excluded middle is no longer an unquestionable principle of logic, I don't believe that there is any real chance of the law of excluded middle being rejected by mathematicians anytime soon. It's fair to say that the intuitionist viewpoint never really caught on in the mathematical community. Intuitionism is a part of the history of mathematics, and of course there may be some useful applications of the intuitionistic ideas, but as I've already said, the principle of the excluded middle is used constantly in modern mathematics, and its use will almost go unnoticed by those mathematicians using it, simply because I suspect that the techniques which rely on it will be used so naturally by mathematicians, and it almost goes without saying that non-constructive proofs are the norm in contemporary mathematics. This is not going to change, in my opinion. To get rid of this principle would require a complete rethink of huge sections of mathematics, and many of the most treasured theorems of mathematics in analysis, algebra, topology, and so on would have to be discarded. I doubt that there are many mathematicians who will have the stomach for that, and I believe there are legitimate reasons for objecting to the use of the law of excluded middle and to scrutinise the principle and its use more carefully. Yet, as convincing as these objections may be, mathematicians do not have to be convinced by them. Since under a classical interpretation, it's understood that either a proposition is true or its contradictory is true, and so assume that we want to prove the proposition P, then it may be possible, rather than proving the proposition P to be true, to instead prove the proposition P is true to be true. To prove the latter indirectly proves the required proposition P. And to illustrate the problem a bit more concretely, let's suppose that we have the proposition A exists, where A is some mathematical object. It's common for modern mathematics to employ non-constructive methods to prove the existence of mathematical objects. Suppose then that we've used a non-constructive method to show that A exists. But what exactly have we proved? We seem to have proved the proposition A exists is true. We haven't provided a construction for the object A, and we haven't shown how A can be uniquely identified, yet we've taken the non-constructive proof as a demonstration of the proposition A exists. And I'm not personally suggesting that this is illegitimate or invalid reasoning, but the intuitionists didn't accept this logical deduction. A proof of A exists has to give a definite, intuitionistically valid construction of the object A, and it does not suffice to instead prove that A exists is true instead. Okay, so that's it for this video. Thank you for watching. If you found this video useful, then please remember to subscribe to this channel and of course hit that like button. Please let me know in the comments section if these videos are interesting and are useful to you. It's always good to hear from people that I've managed to reach. Once again, thank you for taking the time to watch, and I'll see you next time.